This will be for the con assignment residual plots. Okay, so for all of these problems, they give us the scatter plot and the line of best fit. If you recall the formula for calculating a residual, it is actual minus predicted. So the actual is one of the dots or one of the points, and the predicted is the line. Now for this exercise, you might not need the exact formula, okay? But one thing you want to remember is that when the dot or point is below the line, the residual is going to be negative, okay? And when the dot is above the line, that residual is going to be positive. So let's look at our multiple choices. Okay, as you can see, we have answers A, B, and C, and they just plot the residuals for the x-axis. Okay, this would be the x-axis, and they plot the residuals for each x value. So you probably don't need the exact value, just positives and negatives. So I'm just going to pick a few x coordinates. Okay, I'll probably just do the even numbers. All right, this is the x-axis right here. At x equals 2, the residual is going to be negative, okay, because the dot is below the line. At x equals 4, the residual is going to be positive because the dot is above the line. At x equals 6, it's going to be positive, and at x equals 8, it's going to be positive. All right, so let's check out the answers that we get. All right, if I go from 2, 4, 6, 8, it's going to be negative, positive, positive, positive. Let's check it out. Okay, 2, 4, 6, 8, negative, positive, positive, negative. That's no good. All right, negative, positive, positive, positive. I think it's going to be B. Last one. Here they have 2 as positive, so it's definitely answer B. So in this problem here, they just give us the residual plot, and there's only 2 possible choices. Either there appears to be a linear relationship between x and y, or there does not appear to be a linear relationship. So you might want to write this down. There's basically 2 ways to determine if there is no linear relationship. If the residuals have a trend or the residuals are far from the x-axis, then there is no linear relationship. So if we take a look at this plot here, we can see that it kind of has a trend. Okay, you can connect the dots somewhat and see that there's a trend. And also you can see some of these points are far away from the x-axis. So really it meets both of these 2 requirements, and we know that there does not appear to be a linear relationship. All right, so if either of these 2 apply on the plot of the residuals, then there is no linear relationship. For their answer, they said if the points in the plot are randomly scattered above and below the line y equals 0, okay, that's the x-axis, we can conclude that there is a linear relationship. All right, but in this case, there is a pattern that points near the middle of the data are above and points to the extremes are below, so we can conclude a non-linear relationship. All right, so you can see on the extreme ends here, the points are below the x-axis. So again, we have one where they give us the plot of the residuals. Okay, we don't have the actual graph, and they want to know what can you conclude. So answer A, the slope of the least squares regression line is 0. All right, you cannot determine the slope from the residuals, so it's definitely not answer A. When x equals 3, the least squares regression equation underestimates y. All right, let's check it out. Here is the x-axis. Okay, this is x equals 3. And the residual right here is positive. Okay, that means the dot is going to be above the line. All right, so the line is under the actual value. That means the line underestimates. Right, because the line is the predicted and the dot is the actual. So the predicted line underestimated the actual value. That's at x equals 3. So answer B is correct. At x equals 3, the least squares regression line underestimates y. Answer C says it overestimates more often than it underestimates. But we can see that's not true. Okay, the ones underneath the x-axis are the ones where it overestimates, and the ones above are where it underestimates. So I think in this case it overestimated more often. But it doesn't matter because it says choose one answer, and I know that B is correct. So here they show the regression line for the scatter plot, and they want to know which graph shows the residual plot here. Okay, so remember, we don't really need the actual values. Okay, we can just do positive and negative for each one. So let's see, here is the x-axis. At x equals 2, the dot is above the line, so the residual is positive. At x equals 4, the dot is way below the line, so x is negative. At x equals 6, the dot's above the line, that's positive. At x equals 8, that's positive. X equals 10, that's positive. Okay, so if we counted from the even numbers, we have positive, negative, positive, positive, positive. Okay, this is 2, 4, 6, 8, 10. Let's look at the choices. All right, 2 is positive. Right here it's negative, so it's not A. For part B, 2 is positive, 4 is negative, 6 is positive, 8 is positive, and 10 is positive. So I think it's B. Let's double check. Answer C. 2 is positive, 4 is negative. Okay, and right here 4 is positive. We said it's negative, so it's not C. So I know B is correct. Last one, they give us the residual plot, and they want us to say if there is or is not a linear relationship. Okay, remember that if the dots are far away from the x-axis, then it's not linear. Okay, and also if you can make a trend to these points, then it's not linear. All right, but generally speaking, I don't think too many of these are far away from the x-axis. Okay, and I cannot really draw a curve or a line for these points. There's no trend. All right, so I am going to say that this is indeed linear. And they basically said the same thing. Since there is no distinct pattern, we can conclude a linear relationship.